In this video, we're going to talk about the market forces of supply and demand. Supply and demand is easily the most important model in all of economics, and we're going to cover a whole lot of different things in this particular video. If there's anything that I cover in this that you're not familiar with or I cover too quickly, I have lots of other videos that will go into a little bit more depth or maybe start out at a little bit more basic level on some of these topics, and I'll mention those as I go through. And those videos are going to be available on YouTube, so you can take a look at those, or you can contact me if you're not sure, if you don't understand something I do here and you want to know what video you should watch to brush up on it, I can let you know. Let's start by thinking about what we're talking about when we think about a market. So if we talk about the demand and supply model, that is a model that helps us understand how a market functions. In other words, how does the price get determined? How does the quantity that's bought and sold in that market get determined? So we need to be clear on what we are thinking about when we're talking about a market, and the most general definition that I'm going to use is that a market is just a collection of buyers and sellers of a particular good or service. So if you've got buyers and you've got sellers, you've got a market. It can be very formal, like the New York Stock Exchange, or it could be very informal, like an auction in a field or somebody selling hot dogs on a street corner, things like that. You could have lots of different buyers, you could have lots of different sellers, or you could have very few buyers and sellers. You could have only one seller, or you could have only one buyer, and all of those things determine how that market functions. And so what we'll be doing is we'll be talking about lots of different types of markets based upon how many buyers and sellers there are, whether the goods are identical. In this particular chapter, we're going to be thinking about what we call a perfectly competitive market. Oftentimes, I'll just call it a competitive market, but I use the terms competitive market and perfect competition interchangeably. Most textbooks do. So if we're talking about a competitive market, what we're thinking about there are markets that meet a particular set of characteristics. And the first one is that there are lots of buyers and sellers. Lots of buyers and sellers. Now, what that means, if there are lots of buyers and sellers, is that each buyer and seller is small compared to the size of the market. So if you think about yourself in the gasoline market, you're small compared to the size of the market. What that means is the amount of gas that you buy, any particular trip you take to the gas station, is a little tiny fraction of the total amount of gas that's bought and sold in the market. Even a particular gas station, and you think about all the gas that gas station might sell in a particular day, that's going to be a small drop in the bucket compared to the total amount of gas that's sold. So we describe this type of market as or these types of buyers and sellers, when there are lots of them, as being small. And then in a competitive market, the goods are identical. The goods are identical. What matters here is that the consumers treat the goods as being identical. So for example, the gas market is a very good example of a perfectly competitive market. There are lots and lots of buyers and sellers of gas. Gas is gas. If you need gas and you pull into a town, you just look at the price of gas, and that's how you decide. For most people, there may be a few people out there that are very particular about where they buy their gas from, but most of us don't care. You just look at the price and you buy gas if you need gas. So it's a good example of a perfectly competitive market. So in this chapter, that's what we're going to be thinking about, markets that fit this definition. As we go through this, if you're thinking about some conclusion that we get and you think to yourself, well, that's not what I see out there in the real world, you need to stop and say, well, okay, Does what I see in the real world, does that fit these characteristics? For example, most markets are not perfectly competitive. There's another type of market called monopolistic competition you may have heard about. We'll talk about it a little bit. That's a much more common type of market, and things work a little bit differently than they do in this type of market. But this is a good place to start. So this is what we're thinking about when we talk about a market. We're going to be thinking about buyers and sellers of a particular good or service, and we're going to start by thinking about this particular type of market. Let's start by thinking about demand. So we'll think about the buyer's side of the market. That would be the demand side, so the buyers. And I'm going to start by defining a term that I'm going to use a lot, and that's quantity demanded. So quantity demanded, the symbol that I typically use for quantity demanded is Q with a subscript D, although lots of textbooks put the demand, the D as a superscript, and then as a subscript they put the good. So this would be quantity demanded of good X. And I may use these interchangeably. I teach lots of different classes. I use lots of different textbooks in those classes. And these are the two main ways that it's written. So I may, if you see one or the other, just consider them interchangeable. So the definition of quantity demanded is the number of units that buyers are willing and able to buy. Okay? Number of units buyers are willing and able to buy. And we're going to think about one of the main things that determines the number of units that you're willing and able to buy is going to be the price. And so if we think about how the price affects the number of units that you want to buy of something, and we hold everything else constant, we hold your income constant, we hold your preferences constant, we hold the prices of other goods and services constant, then you realize real quickly that as something gets more expensive, you want to buy less of it. And as it gets less expensive, you want to buy more, all other things held constant. And so what we would say is that an increase in price will lead to a decrease in quantity demanded. They move in opposite directions. They're inversely related or negatively related. In fact, we call that the law of demand. So most textbooks will define the law of demand this way. It will say that the law of demand says that all other things held constant, price and quantity demanded move in opposite directions. That phrase, all other things held constant, some textbooks use the Latin phrase for all else equal. It's ceteris paribus. So you may hear somebody say ceteris paribus, if price goes up, quantity goes down. Well, that ceteris paribus simply means hold everything else constant. I won't use that term. I will just say hold everything else constant or all else equal. So that's the law of demand. Let's talk about why. Why is there this inverse relationship between the price of the good and the number of units that you want to buy? And it boils down to two things. There are two things that happen when price changes. One of them is what we call a substitution effect. Substitution effect. And the other one is what we call an income effect. So let me just briefly describe what those two things mean. Let's start with the substitution effect, and I'm going to think about it in terms of the price of something going up. So if the price of something that you buy goes up, then other things are becoming cheaper in comparison. And you tend to substitute away from the thing that's price is going up towards other things. So for example, let's suppose you like to eat pizza, but the price of pizza goes up. Well, then that means that in comparison, other things like hamburgers are getting relatively cheaper. And so you may substitute away from pizza because its price is going up and instead buy more hamburgers. You may not substitute completely away. You may just buy less pizza and more hamburgers. So that's the substitution effect. The income effect says that when the price of something that you buy goes up, that has an adverse impact on your income. And when your income goes down, you tend to buy less of most things. So if the price of pizza goes up, it's like you get a cut in your income, a little tiny cut in your income, and you eat less because of that. So those are the two reasons that we have this inverse relationship between price and quantity demanded. Now, if we wanted to graph that relationship between price and quantity demanded, the way that we draw that typically is that we put price on the vertical axis and we put quantity demanded on the horizontal axis. And the fact that they are inversely related to each other or negatively related to each other means that that demand curve that we draw is going to be downward sloping. Okay? What this means is if we were to pick a point on this demand curve, suppose this is our price, let's say we've got a price like P1, and we go over to the demand curve and we see the quantity that we want to buy at that price of P1, it's going to be Q1. If we increase the price and we look at the effect that that has on the quantity demanded, we see that quantity demanded falls, right? When we increase price to P2, our quantity demanded falls from Q1 to Q2. So that's why a demand curve is slopes downward. It reflects this law of demand. Okay? Now, let's think about if we wanted to write a mathematical function for a demand curve. Now, first off, let's talk about the name demand curve. I'm going to call it a demand curve, but you may notice that it's a line, and you might say, well, why don't we call it a demand line? Well, we just always call it a demand curve, even if it's linear. In the real world, demand curves typically are not linear, but mathematically that's way easier to work with than a nonlinear function. So anything that we did in here, I would keep it nice and simple and it would be a linear demand curve, okay? So let's suppose that we thought about a mathematical representation of a demand curve, and let's think about a nice simple one. Let's suppose I said that the demand curve looked like this. P equals 10 minus 2Q, and I'm going to put QD for quantity demanded. P equals 10 minus 2Q. So that's a function of a line in slope-intercept form. This is your vertical intercept, and this is your slope. And it's easy to graph that. If we wanted to graph this particular demand curve, it would look like this. I'm going to put price up here, quantity demanded down here. This has a vertical intercept of 10, so I'm going to put 10 up there. And it's got a slope of -2. Now remember that slope is just 2 over 1, and it's the rise over the run. So the slope, let me put up here, slope, remember, is equal to rise over run. Well, if the slope is -2, that means you go down 2 over 1, down 2 over 1. Well, that means by the time you've gone down 10, you will have gone over 5. And so this particular demand curve is very steep. It looks like that. It's a very steep demand curve. And the slope of this is -2. Okay. So that's what that particular demand curve would look like if we drew it. What we could do is then, if you know the functional form of the demand curve, you can figure out the quantity demanded at all of the prices along this vertical axis. So for example, suppose price is equal to, let's say 8. Well, if price is equal to 8, then I'm going to plug that price into this demand curve right there. Okay, and I'm going to say that 8 equals 10 minus 2Q. I'm going to leave the D off, okay? I want to solve for Q now, so I'm going to move my Q to the other side, and I'm going to subtract 8 from this side. That gives me 2Q equals 10 minus the 8, that's 2. I'm going to divide through by 2. That's, these cancel, I get Q equals 1. What that means is that if I were to pick a price of 8 and plug that into the demand curve, out of that pops a quantity of 1. If the price is 8, this person wants to buy 1 unit. If the price is 10, they want to buy 0 units. Okay? And so you can see as the price goes down, they want to buy more units. If we started down here and increased the price, they would want to buy less. So the idea behind a demand curve is very straightforward, and mathematically, if we're dealing with a linear demand curve, it's also very straightforward. Okay? It's just the function of a line. Now, what I want to do is I want to talk about this name demand curve for just a second. Let's start by doing this. If I take this demand curve, I'm going to rewrite it right here. I'm going to say P equals 10 minus 2Q. I'll go ahead and put my D back in there. I'm going to invert that function. I'm going to solve it for Q. Okay, so I'm not going to plug anything in for P. I'm going to leave P where it is, or P as the letter P, and I'm going to solve for Q. So I'm going to move this 2Q over here, and I'm going to move my P over there. So I can rewrite this with a little bit of algebra as 2QD equals 10 minus P. I haven't done anything. I just moved my P to the other side, and I moved my 2Q over here. Because when I solve for something, I like it to be on the left-hand side. Now, I want Q over here. I've got 2Q, so I need to divide through by 2. I'm going to divide both sides by 2. My 2 is going to cancel out there, and it's going to leave me what I want, and that's just Q over here. And then I've got 10 minus P divided by 2. Well, I can separate that out into 10 over 2 minus P over 2. All right? It's the same thing, which is Q equals 5 minus P over 2. Now, this is the same mathematical relationship between P and Q as that is. I've just inverted it. I've solved for the other variable. Okay, so now I've got Q on the left-hand side. Let me just also say that sometimes students, if it's been a while since you've done this, sometimes this thing causes a little bit of confusion. This is the same as this. If I wrote it like this, 5 minus 1/2 times P. That's the same thing. So this is also slope-intercept. Here's my vertical intercept, and here's a slope. Okay? But now here's what I have done. By inverting this function, I also invert the picture. So I'm going to draw the picture now, and when I invert it, instead of having P on the vertical axis, now I've got Q up there. And I've got P down here. So inverting a function mathematically like this, it's the same as taking it and flipping it that way. So what was your horizontal axis becomes your vertical axis. Now, let's graph this function right up here. Well, this one has an intercept of 5, a vertical intercept of 5, and it has a slope of -1/2. So that means the rise is -1, and the run is 2. So I go down 1 over 2, down 1 over 2. By the time I've gone down 5, I will have gone over 10. And so this thing, when I invert it, looks like that. And it has a slope of -1/2. Now here's what you need to do. You need to look at these and convince yourself that these represent the same relationship between price and quantity. The only difference is how we're looking at it. We've got one of them solved for P, and we've got the other one solved for Q. This is always how we graph a demand curve. Like when you see a picture, when I draw demand supply pictures, I'm always going to be putting price up here. I'm only showing you this because there's an important distinction here. This thing is actually what we call the demand curve. Mathematically, that is known as the demand curve. And this thing is known as the inverse demand curve. So if you hear me say the word inverse demand curve, this is what I'm referring to. Now let's talk about why we call this the demand curve and why we call that the inverse demand curve. I can tell you this will not be a big issue as we move through the class. What we're going to do is all of our pictures are going to be drawn this way with P on the vertical axis. And I'm typically going to be talking about it in terms of this form, usually, okay? But let's talk about what's going on here. So the story that I talked about right here, and the way that we make decisions is what we do is we go out, imagine you go to Walmart, and you're going to do some shopping. The thing that you look at in terms of the decision that you make, one of the main things that you look at is the price of the goods that are available for you to buy. And you look at that price and you decide if you're going to buy it or not buy it, and then how many units. If you're going to buy it, how many units are you going to buy? So am I going to buy milk today? Well, I can look at the price of milk and then I say, okay, should I buy 1 gallon or 2 gallons? It depends on the price. If you get there and milk is really expensive, you may decide not to buy any milk that day. Or if you get there and they have a sale on milk, you might decide to buy 2 gallons. But we're always looking at the price and we decide the number of units that we're going to buy. Well, that story fits this function. We look at the price and we plug the price in, and out of that pops the quantity. So this way of looking at things mathematically fits the story of how we all behave. This is why we call it the demand curve. But when we graph it, what we do is we invert it. We invert that thing mathematically, and the reason that we did that goes back to an economist a century ago named Alfred Marshall that wrote a textbook, and Alfred decided that he would make his demand curves look like this and his pictures look like that. We've been doing it ever since. But it doesn't fit the story, right? Because this says the quantity determines the price. And if we're thinking about the way a market functions, there's nothing wrong with that. There's actually nothing wrong with looking at it either way. I just want you to be aware that there are two ways to look at it, and you might hear me say the phrase inverse demand curve, and if I do, that's what I'm referring to, Okay, so that was a whole lot of stuff on something that's actually very simple. These are just two ways to look at the exact same mathematical function. They're inverses of each other. Let's talk about, now that we understand why a demand curve is downward sloping, the income and substitution effects, let's talk about the things that cause a demand curve to shift. Okay, so I'm going to call these the determinants of demand. Determinants of demand. These are just determinants of demand. These are things that shift demand curves. Some textbooks call them demand shifters. The first one, and probably one of the most important, is your income. So if you think about a particular good or a particular service and the amount of it that you buy, well, your income changing, that can have impacts on the number of units that you buy. So as an example, let's suppose that you think about the number of times in a typical month that you eat out at a restaurant. And then imagine what would happen if your income got cut in half. If your income got cut in half, you'd probably eat out at restaurants less often. Or we could go the other way. What if you won the lottery and now you don't have to worry about how much money you spend? Well, you'd probably eat out at restaurants more often. So your changes in your income can cause these demand curves to shift. There are two types of goods that we talk about. The first is what we would call a normal good. A normal good is a good for which an increase in income increases demand. So let's write that. An increase in income increases demand. Most goods are that way. For example, eating out at a restaurant. If you like to eat out at a restaurant, then if your income goes up, you typically, all other things equal, would eat out at a restaurant more often. I'm going to say vice versa because you need to be aware that you can reverse this. A decrease in income will decrease demand. That's how it works for most goods and services. But then there are some goods that we call inferior goods. A good is an inferior good if an increase in your income causes you to buy less of it. This is more rare, but there are goods that are like this. For example, ramen noodles is kind of the textbook example of an inferior good. When you don't have very much money, then you probably, all other things equal, if you liked ramen noodles, would tend to, let's say you eat some ramen noodles. You don't have a lot of money. When I was in college, I ate ramen noodles. As my income has gone up, I've moved away from that and I buy other things to eat. I haven't eaten ramen noodles in decades. So that is an example of a good for which, as my income went up, I moved away from it. I ate less of it. There are other things like public transportation or used clothing or banquet pot pies. There are lots of things, generic brands, where as your income goes up, you buy less of them. And if your income goes down, you buy more. So let's write that. An increase in income decreases demand. Increase in income decreases demand. And I'm going to say vice versa. You may, as I told that story, you might have been thinking, banquet pot pies, I love banquet pot pies. In fact, I do. For me, banquet pot pies aren't an inferior good. They're actually a normal good. I ate a lot of banquet pot pies when I was young in college, and I liked them so much that as I got older and made more money, and I ate even more of them. The only reason I don't eat them these days is it turns out they're not that healthy to eat. So if you like them, be careful because there will come a day when you probably shouldn't eat them. All that means is that for me, banquet pot pies are a normal good, not an inferior good. In other words, whether a good is a normal good or an inferior good is a characteristic of your preferences, not the good itself. So if you thought to yourself, when I said that public transportation is an inferior good, if you thought to yourself, well, I love riding the bus. Well, fine. For you, it could be normal. For a lot of people, it's an inferior good. When their income goes up, they tend to buy a car and then they have more control over their transportation. So that's income. Let's talk about another determinant of demand, and that's going to be the prices of related goods. Prices of related goods. I'm going to underline the individual determinants here. Your demand for a particular good can change if the prices of other goods that it is related to changes. Now, how a good is related to other goods can fall into one of three categories. First off, it could be completely unrelated to another good. So, for example, your demand for tires is probably completely unrelated to the price of sugar. If the price of sugar changed, it wouldn't have any impact on your demand for tires. But if two goods are related, then they will be related in one of two ways. And the first way is that they can substitute for each other. So you either buy one or the other. So for example, the classic case of substitutes would be Coke and Pepsi. Most people are comfortable with either. If they ask for a Coke and at a restaurant, somebody says, "Is Pepsi okay?" Most people will say yes. They are substitutes. Or you could have a situation where two goods are complements for each other. Substitutes, you buy one or the other. Complements, you tend to consume them together. So complements, those are things like peanut butter and jelly. Okay? So let's start with substitutes. I'm going to put substitutes down here. Substitutes. So substitutes, that's an example where if the price of one good goes up, you'll buy less of that good and substitute towards the other good. So if the price of one good goes up, that'll increase your demand for the other. So I'm going to say here an increase in price, of one good increases demand for the other. That's the story that I told you with the substitutes over here. This is the substitution effect. If the price of pizzas goes up, people will buy less pizza and increase their demand for things that can substitute for pizza, like hamburgers. So an increase in the price of one increases demand for the other because you substitute away from the good whose price is going up. I don't have room to write it there, but you need to be aware that a decrease in the price of one decreases demand for the other. So that's how it works for substitutes. Let's do complements. I'm going to put it up here. Complements, and that's complements with an E. That's a situation where an increase in the price of one of the goods causes you to buy less of that good and less of the things that go with it. Okay, so an increase, let me write it symbolically. An increase in the price of one good decreases your demand for the other. Decreases demand for the other good. And vice versa. An example would be, let's suppose that you go and you're going to grill out and you want to buy some hot dogs. And so you go to the store and you pick up a pack of hot dogs and you go over to get the buns. And you see that the buns are really expensive. And so expensive that you think to yourself, I'm not going to buy those buns. Well, if you're not going to buy the buns, you're probably not going to buy the hot dogs either. So the increase in the price of the buns reduced your demand for the hot dogs. So that's how it works with complements. So that's the, now we've talked about income, we've talked about the prices of related goods. There are three others. I don't need much space to write them, so I'm going to put the third one up here. That's your tastes or your preferences. Let me underline that one as well. This one's straightforward. If your tastes for something change, that obviously is going to shift your demand curve for that. So for example, your taste can change based on things like advertising, or maybe you see a commercial that says that a diet low in or high in certain types of foods could lead to better health. You might buy those foods because you want to be healthy. So tastes, we don't really need to write anything under that. Another determinant is your expectations about the future. I'm just going to say expectations. Your expectations about, say, future price, so it could be about future price, or it could be about your future income. Suppose you expect the price of some good to go up in the future. You might buy more now before that price increase. So that expectation of a higher price in the future could increase your demand for it right now. And then the last determinant of demand is going to be the number of buyers in the market. Number of buyers. So that's 5 things. Here's number 1. There was number 2. Number 3, 4, and 5. 5 determinants of demand. I'm going to clear this off, and then we're going to talk about the difference between a change in demand and what I'm going to call a change in quantity demanded. All right, let's talk about a change in demand versus a change in quantity demanded. They sound like the same thing, but they're different. So let's talk about a demand curve. If we're thinking about a change in quantity demanded, remember that's what we started out with over here, and we talked about an increase in price causes a decrease in quantity demanded. A change in quantity demanded is what we're thinking about if we consider the effect of a change in price. So at P1, the quantity demanded is Q1, and if price goes up to P2, we have a decrease in quantity demanded to Q2. That's a change in quantity demanded. It's a movement from point 1 to point 2 on a demand curve. That's different from what we're talking about if we think about a change in demand. If we're thinking about a change in demand, then what I'm going to be talking about is a shift of that demand curve. So if we have a change in demand, I would call that, say, demand curve D1. If we had an increase in demand, that means my demand curve has shifted to D2. The whole curve is shifted. Or we could have a decrease in demand if it shifts to the left. This is caused by one of the determinants of demand. Income, prices of related goods, the stuff we just talked about. This one's determined by price, or is caused by price, and the reason is because we've got price on the vertical axis. If you change something on one of the axes, you just move to a new point on it. But if we change income, income is not on the axis. So if we change income, the whole curve shifts. And I'll show you that here in just a second. Let's talk about the demand function. Demand function. So a demand function simply tells you how much of a particular good a consumer is going to purchase depending upon the prices of, or the price of the good and those other determinants of demand. So it's going to look like the demand curve that I had up here. Remember, we had an inverse demand curve and a demand curve. It's going to look like that, only it's going to at first look more complicated. But I think you'll see real quickly it's not more complicated. So let's think about demand for good X, and I'm going to use this notation. That's going to be quantity demanded of good X, and I'm going to write it as a function of the price of good X, which I'm going to call PX, and then I'm going to add the determinants. So I'm going to say it's also going to be a function of the consumer's income, the price of a related good, good Y. I'm going to put one more thing in there. It's going to be advertising on good X. We're not going to put expectations or the number of buyers into that. That's not where that goes. So this F, if you're not familiar with that notation, this just means it's just some general function. I'll show it to you here in just a second. So the number of units of good X that the consumer buys is, of course, determined by the price of good X, but also by these other determinants, the consumer's determinants. Consumer's income, the price of a related good, good Y, and the advertising that the consumer sees about good X. Let me give you an example. We can just keep it linear. I'm going to say that quantity of good X demanded will be equal to 1,000 minus 2 times the price of X minus 1 times M, income, plus 4 times the price of good Y, plus 2 times A, which is advertising. Looks complicated. It's actually not complicated. Here's what it tells us. It just simply says that the number of units that the consumer wants to buy is a function of all of these things that we've just talked about. Okay? And what we could do is we could plug in values for these, and we could figure out if the price of good X is this, and income is that, and the price of good Y is that, and advertising is this, then how many units is the consumer going to want to buy? Let's talk first about the signs in here. Why did I make some of these things negative and some of them positive? Well, this has to do with the law of demand, right? If the price of good X goes up, because of this negative sign, the consumer's going to want to buy less of good X, right? This is the downward slope of the demand curve that's right there. Think about the negative sign on income. If I increase M because of that negative sign, it makes the quantity of X go down. In other words, the negative sign right there means that good X is an inferior good. As income goes up, the consumer buys less because of that negative sign. Let's think about this positive sign on the price of good Y. This means that if the price of good Y goes up, the consumer will, of course, buy less good Y, but because of this negative sign, they'll buy more good X. In other words, they'll substitute away from good Y towards good X. That positive sign means that goods Y and X are substitutes for each other. This positive sign on advertising means that the more dollars that are spent on advertising for good X, the more the consumer buys of good X. In other words, the advertising works. And if that sign was negative, it would say that advertising causes a decrease in demand for good X. So these signs tell you about how these determinants of demand work in this particular case. Now, what we can do, as I said, we can plug in some values for this. Let's do that. Let's suppose that I'm going to pick values for these three things. And you'll see why I'm not going to pick a value for good X yet. Watch. So let's suppose income is equal to 100. Let's suppose the price of good Y is equal to 20 and advertising spent on good X is $100. Now I'm going to plug those in right there. And here's what I'm going to get. I'm going to get that the quantity of good X demanded is equal to 1,000 minus 2 times the price of good X minus 1 times 100 plus 4 times 20 plus 2 times 100. This is equal to 1,000 minus 2px minus 100, that should be 100, plus 80 plus 200. So this, negative 100 plus 200, that's 100, plus another 80, that's 180. I can add that over here. That's equal to 1180 minus 2px. Right there. These terms just become just numbers, and I just add those to the intercept. Now, no, look at that. That's just the demand curve function that I showed you just a little bit ago, right? This is what we would graph, right? It just shows us a relationship between the quantity of good X demanded and the price of good X, right? Now, it's the demand curve. It's solved for Q. So it would be the inverse of the picture where we've got P up there on the vertical axis. But if we solved this for P and then graphed it, we'd have our demand curve. Or it would be an inverse demand curve, but it would be equivalent to that picture. So you can see that this starts out looking really complicated, but as soon as you pick values for this, you get a very simple linear function. The numbers aren't quite as easy to work with as the example I gave you before, but it's still just a linear function. Here's your intercept, there's your slope. All right, let's talk about a market demand curve. So I've been thinking about this in terms of an individual person's demand curve. That's how I've motivated all of what we've talked about right now, an individual person's demand curve. What we're interested in is the market. And if we're thinking about how a market works, what we need is the market demand curve. Well, the market demand curve is just the summation of all of the individual demand curves. So if you had a demand curve for this person and a demand curve for other people, you would just add them together. What we would be doing graphically is this. If I had a person here and here's their demand curve, and I had another person with a demand curve, they don't have to be the same demand curve. And then I wanted to add those two demand curves together. Here we would have P, Q, P, Q, P, Q. And over here I'm going to have the market. Then all we'd be doing is we'd be saying, okay, let's pick a price like P1. Let's see how much at that price this person wants to buy. It would be Q1. Let's say this is person A, so I'm going to put a little A there. At that same price of P1, this person wants to buy this amount. We'll call it Q1B. So this is person A. This is person B. Well, that tells us that if these are the only two buyers in the market, then at that price of P1, the total quantity demanded in the market is going to be the sum of this amount and that amount. It's going to be Q1A plus Q1B. And the market demand curve would just be the horizontal summation of the individual people's demand curve. What we're going to be doing is we're going to be thinking about market demand curves. We'll put it together with a market supply curve, and that's how we're going to think about the way that a market works. So this market demand curve is one curve that represents multiple buyers. Let's talk about something, a concept known as consumer surplus. If you're not familiar with consumer surplus, or if anything that I talked about with the demand curves didn't make sense, or you want a more thorough explanation for some of that, you can go to the demand and supply videos in my Principles of Micro or Principles of Macro classes. Those are on YouTube. You could search, go to my channel, go to the playlists, and you'll see the playlist for Principles of Micro and Principles of Macro. Pick one or the other because the video's in, the demand supply one is in both of them. If you're interested in a little bit more, if what I talk about here on consumer surplus, you need a little bit more on it, then go to my Principles of Micro class and you'll see a consumer surplus video. So consumer surplus is simply our way of measuring the well-being that buyers get from purchasing a good. Okay? So let's start by talking about value, the value that you place on something. So the value that you place on something, economists measure that by using what we would describe as your willingness to pay. So your willingness to pay for something, the more you value it, the more you're willing to pay for it. And that works really well as a measure of the value that you place on something because it represents your willingness to give up other goods and services to get the thing that we're talking about. So we use willingness to pay, measured as willingness to pay. And I'm going to abbreviate willingness to pay, WTP. Okay, so that's going to be how we measure the value that a consumer places on something. Let's think about the way that a demand curve works. And I'm going to go back here to thinking about my demand curve just like this. I'm calling it a demand curve even though we know that it's actually an inverse demand curve. But let's think about a demand curve. So the way that I have talked about the demand curve up to this point is I've said, okay, let's pick a price and let's go over to the demand curve to see the quantity demanded at that price. That's fine. That's a perfectly useful way to use a demand curve. Another way to use a demand curve is to start with the quantity and say, okay, let's think about that quantity right there, Q1. Well, the height of the demand curve, if we go up to the demand curve, it tells us the number of dollars that the consumer is willing to give up to have that particular level of output or that particular number of units of the good. In other words, the height of the demand curve represents the consumer's willingness to pay for that quantity. And you can see that at low quantities, the consumer is willing to pay more. And if the consumer has a high quantity, their willingness to pay is less. In other words, the more of something you have, the less you're willing to pay to get a little bit more. Your willingness to pay for something declines the more of it you have. It's the reason that when you're hungry and you go to a buffet and you sit down to eat, that first bite is the best. And as you eat more and more bites and your hunger gets satisfied, the value you place on one more bite is going down. And by the time that you're full and you've got that last bite and you're full, your willingness to pay for one more bite is practically zero. You could be talked out of taking that last bite probably very easily. So the height of the demand curve represents value. In fact, a lot of times when I'm talking about consumer surplus and value, I will label the demand curve as a value curve because that's what it is. So let's suppose that a consumer has a willingness to pay of $20 for some particular good. Maybe it's a shirt. Okay, so the consumer's willing to pay $20. If the price was $21, they wouldn't buy it. If the price was $40, they wouldn't buy it. If the price was $20, they would buy it. And of course, if the price was less than $20, they would buy it. And if the price was less than $20, they'd buy it and they'd be happy about it. And we can come up with a way of measuring the well-being that they would get. Let's suppose that the price is only $12. Suppose the price is equal to $12. So they're willing to pay $20, but they only have to pay $12. Then what we would say is that the consumer gets what we would call $8 of consumer surplus. So we say the consumer gets $8 of consumer surplus. We abbreviate consumer surplus CS. They were willing to pay $20. They gave up $12, and that left them with $8 of value that they were willing to give up but didn't have to because the price was only $12. And they're happy about that. They can spend that $8 on something else. So the consumer surplus that a consumer gets is a measure of the well-being that they get out of that transaction. You can see that the lower prices are, the more consumer surplus you get. So it's a very good way of measuring the well-being of consumers. The way that we're calculating that is that consumer surplus is equal to willingness to pay minus the price. So in our example, willingness to pay was 20. We subtracted off the price of 12. That left us with the 8. So that's where the 8 came from. Can't see that very well. There it is. So that's how you calculate consumer surplus for one transaction. If we're thinking about the consumer buying multiple units, so if the consumer doesn't just make one transaction where they buy one shirt, let's suppose they buy multiple units of something, then the consumer surplus ends up being the area under the demand curve and above the price. So if the consumer has bought all of these units up to that amount, then consumer surplus ends up being that area under the demand curve and above the price. And the reason is that at these low units, the small number of units that they're buying, they have a high willingness to pay. The price is right there, so that distance right there represents the consumer surplus they get from these first units, and then they buy more and more units. The price is the same, but their willingness to pay is declining. So the consumer surplus that they get from multiple units ends up being all of that area. Let's do a quick example. Let's suppose that I gave you a picture that looks like this. Suppose the intercept is 20, the price is 12, and the total quantity that the consumer buys is 100 units. So we're interested in the consumer surplus that they get, not just from one unit, but from all of these 100 units. It's going to be this area. And the way you calculate that area, the consumer surplus, is equal to this vertical distance, which is, remember, if you're calculating the area of a triangle, it's half of a rectangle. Well, the area of a rectangle is height times width. Well, the triangle is half of that. So we need height times width divided by 2. Our height is 8. Our width down here is 100. We're going to divide by 2. That gives us $400 of consumer surplus. So if you're just buying one unit, your consumer surplus is just a simple one number minus another. If you're buying multiple units, it shows up as an area. Now, make sure I went over consumer surplus very fast. And if you've just had an economics class recently, that's probably familiar with you or familiar to you. If you haven't, or maybe this is your first exposure to consumer surplus, I highly recommend going and searching my channel for consumer surplus and watch a more thorough discussion of this. What we're going to do in the next video is we're going to talk about supply, and we're going to go through all of the stuff that we did here with demand, except we're going to be thinking about supply. So I'll see you in that video.